everyone, welcome students to the solution video for um, June 2024 IAL Chemistry Unit 5. So this was the one of the most sought after video, and stick to the end of the video for the entire solution, and I'll explain the entire paper along the way, so stay tuned. Okay, we start with section A. Question 1. What color is vanadium 3 in aqueous solution? You need to memorize some of the colors of the transition metals and at their respective oxidation states. So vanadium 3 we know is green. Therefore, the easy answer is number 1, which is green. Question 2. An oxide of vanadium is the catalyst in one step of the contact process for the manufacture of sulfuric acid. Which reaction involves the vanadium oxide catalyst, and how does the oxidation number of vanadium changes during the process? Okay, so here, what does vanadium do? What does this vanadium oxide? So the vanadium oxide we use is V2O5, right? V2 of vanadium pentoxide. So vanadium pentoxide is used to catalyze the reaction of what? To catalyze the reaction of SO2 to SO3. Remember, the reaction is like this. So V2O5 becomes V2O4, and along the way it catalyzes the reaction of SO2 to SO3, and then it oxidizes again to V2O5. It then oxidizes again to V2O5. So at first, so V2O5 reacts with SO2 and it forms V2O4. So the change in oxidation state here, the oxidation state of vanadium was +5, and here it's +4. So it changes from +5 to +4, and then back to +5 again. Since it's a catalyst, it should remain unchanged at the end of the reaction. So here you can see the only option here is C, because in C we have the reaction of SO2 to SO3. So SO2 converts to SO3, and the oxidation state of vanadium changes from +5 to +4, and then again to +5. Next question says an equation for the reaction of FeSO4 iron sulfate with potassium manganate is shown. Okay, this is our reaction, and which shows the changes in the oxidation states for iron and manganese. So here the oxidation state of iron is +2, and here it's +3. And for manganate ion, the oxidation state of manganese here is, since this is MnO4 minus ion, therefore the oxidation state is +7, and here it's +2. So iron changes from +2 to +3, and manganese changes from 7 to 2. So our answer is A. 3B says a 25 cubic centimeter sample of iron sulfate dissolved in acid required 22.5 cubic centimeter of this concentration of potassium manganate. So we need to find out the concentration of FeSO4. So here we can find out the mole of what, potassium manganate. So that would be 0.1 times 22.5 divided by 1000. Now this, if we calculate, gives us, so 0.1 times 22.5 divided by 1000 is 2.25 into 10 to the power 25 into 10 to the power minus 3. Now from the reaction we can see that 2 moles of manganate ion reacts with 10 moles of iron sulfate. Therefore the mole ratio is what? The mole ratio is 1:5. That means if we have this much mole of manganate, the mole of iron will be, mole of FeSO4 would be 5 times of this. So 2.25 times 10 to the power minus 3 times 5 will be equal to 0.1125. This is our mole. Now this is the amount of mole of iron sulfate in what? In 25 cubic centimeters, but we need to find it in how much mole is in 1 cubic decimeter. So just for that, so 1 cubic decimeter is 1000 cubic centimeters. Divide this by 25, we get 40. So basically this mole times 40, 0.01125 times 40 gives us our required answer. So that is equal to 0.45 Therefore, our answer is C, 0.450 mole per cubic decimeter. Then we have the EMF E cell of the cell made up of the copper and magnesium half cells is measured under standard conditions. The voltmeter used has a measurement uncertainty of 0.5%. What is the highest EMF that could be measured in this experiment? So you just look at your data booklet and find out the uh, search for the standard electrode reactions for copper 2 plus 2 copper and magnesium 2 plus 2 magnesium, and you'll see that the EMF or the E cell value comes around at 2.71 volt. Now we don't have the 2.71 answer here, but we have an inaccuracy of 0.5%. So we can see that for 2. So the closest are 0.2.7 and 2.72. So if we calculate for 2.72, so 2.72 minus 2.71 divided by 2.71 into 100 this gives us 2.72 minus 2.71 divided by 2.71 times 100 gives us 0.0.4, right? 0.4%. So this is within our uncertainty value, and we needed to find the highest EMF, not the lowest. So since it's the highest, so we will take the highest value. Therefore, the answer is B. For number 5, which of the diagram for the cell made up of nickel and zinc half cells that gives a positive? Okay, so positive value for E cell positive value, that means the reaction will proceed, and we know that zinc is more reactive than what? Than nickel. Zinc is more reactive than nickel. So this means that zinc, the reaction of zinc will be zinc will form Zn2 plus ions, right? Zinc will form Zn2 plus ions by losing 2 electrons, and nickel will be nickel 2 plus will gain those 2 electrons to form nickel. So our required the correct answer is, so Zn Zn loses 2 electrons to form Zn2 plus, and Ni, or nickel 2 plus, gains those 2 electrons to form nickel. So our answer is A. Next, which graph shows the relationship between E cell plotted on the x-axis and the entropy on the y-axis for any electrochemical system? So we already know that the E cell value and the entropy are directly proportional. That means if E cell increases, and so will the entropy. That means our graph, since they are directly proportional, that means our graph would be a straight line with a positive gradient. So here the only straight line with a positive gradient and going through the origin. So since when E cell is 0, our entropy is 0, the answer would be A. Do not write this answer. For question 7, which type of data is not used as evidence for the structure or stability of the benzene ring? Okay, so we can differentiate from the benzene ring or this structure from other structures by, if we do infrared spectroscopy, we can find out that about the different carbon environments here. So this is correct. This can be used. Mass spectrometry. So mass spectrometry cannot be used. This will be our answer because say this is a compound with 6 carbon atoms, and then we have another carbon atom with like this, an alkane with 6 carbon atoms, 1 2 3 4 5 6. Like for mass spectrometry, both of them will give the same result, the same values. That means we using mass spectrometry, we cannot differentiate between these two. For thermochemical, we can. For X-ray diffraction, you have studied in your books that we can differentiate between these two using these two processes, but only mass spectrometry is the one that is not able to differentiate between the two structures. The formation of nitrobenzene requires benzene and concentrated nitric acid and sulfuric acid, which is an equation for the reaction to form the electrophile. Okay, so the electrophile for nitrobenzene is NO2 plus, right? So we need that. So we can just eliminate option C and D since there is no NO2 plus here. So it's between A and B, right? So here our correct answer would be B. This is because that for A, almost everything is same, but here SO4 2 minus is produced. And SO4 2 minus is will not be produced because it's like um, it's too acidic for that. So SO4 2 minus is not readily produced anywhere. It would be HSO4 minus and H3O plus. Our correct answer is B. Phenol reacts with bromine to form 2,4,6-tribromophenol. Okay, this is our reaction. And what is the percentage atom economy? So atom economy, what is the formula for atom economy? Atom economy is the mass of desired product divided by the mass of the total product, right? Mass of total products. So if you just do this, so our desired product is this, so this is 330.7, so 330.7 divided by total product is 330.7 plus we have 3 hydrogen bromides, so 3 times 80.9 into 100 will give us 57.7, and our answer is B. Okay, for B, when 5 gram of phenol was reacted with and purified, the percentage yield of 2,4,6-tribromophenol was 76.8. What mass of purified? Okay, we need to find out the mass of tribromophenol. So we had 5 gram of phenol, so 5 mole of phenol. We can find out the mole of phenol, and that would be 5 divided by what was the MR of phenol. So phenol MR is 94, so 5 divided by 94 is the mole of phenol. And therefore, what is our mole ratio? Our mole ratio is 1:1. Therefore, the mole for tribromophenol is the same, but we have a percentage yield. So what was the formula for percentage yield? Percentage yield is equal to the actual mole divided by theoretical mole, right? So we have found this is the theoretical mole. So the actual mole of tribromophenol would be percentage yield is 76, so 0.768 times the theoretical mole, which is 5/94, and we will find that 0.768 into 5 divided by 94 gives us 0.041. So 0.041, this is our actual mole of tribromophenol produced, and if we just multiply this with the mass number, which is 330.7, we get the mass. So times 330.7 is 13.5, and B is our answer. Next question. Aspartic acid is a naturally occurring amino acid. Which form of aspartic acid is formed at pH 12? So this pH 12 means it's an alkaline condition. So therefore, since this is an acid, so the acids will lose. So from here, so acid means COOH. So this will lose this H plus, right? This will lose this H plus and form a CO minus. So we need COO minus, 2 COO minus in this acid. And which configuration actually shows that? It's C. Here C, both the COO, the carboxylic acids lose the hydrogen because of the because of the alkaline condition. So this is our answer. Now glutamine is shown. This is the structure of glutamine, and then which is a correct structure when aspartic acid forms a dipeptide with glutamine? Okay, here we can see that here our structure for this acid, this peptide was this amino acid was this, right? So we have two carbon chains in the middle, and we have 2 carboxylic acids at 2 ends, and similarly glutamine has 1 carboxylic acid at one end and 1 amide group at the other end. So the only position that this will form an amide group is with this NH2. So this NH2 will react with the carboxylic acids here and form the dipeptide. So we need to look at which structure actually shows that. here I think it's D is the answer, because here this was our aspartic acid, right? So CONH, this NH is then connected to the C was in the second carbon atom. The first carbon atom had the carboxylic acid group here, and so on, and the chain continues. So D is our answer. You have to look a little bit closely, you have to think a little bit for this type of question, but it's easy if you just understand the structure and how and where the bonds are formed. Okay, what is the maximum number of chiral centers in the dipeptide? So chiral center means one carbon atom will be connected, will be bonded with four separate different groups. So here you can see that this specific carbon atom has one is that one bond is like one hand of the carbon is bonded with NH2, one is with H, one is with this, and the other is this. So this is a chiral carbon, and another chiral carbon we can find is this one. See, this is different, this is different, this is different, and this is different. So they both of them are two chiral carbons. Therefore, our answer is 2. Question number 11 says a student prepared a sample of aspirin. The equation for the reaction is shown. Okay, then the aspirin was recrystallized using an ethanol water mixture as the solvent. The student determined its melting temperature using the apparatus shown. Okay, so the student sample melted over a range of 8 degrees starting at 125 degrees, and the published melting temperature of pure aspirin is 135. So what is the suitable liquid that can go in the beaker? Okay, is it deionized water? See, water boils at what? Water boils at 100 degrees Celsius, and here the melting temperature is 135. That means we cannot use water. Ethanol, we can't use ethanol because we have the one of the products is ethanoic acid, and ethanol will react with ethanoic acid to form an ester. We cannot use that. We cannot use hexane either, because similarly, boiling point is below boiling point of hexane is below 135 degrees Celsius. Therefore, the only thing is left is mineral oil. Mineral oil does not react with any of the products shown or even the reactants. Therefore, we can easily use mineral oil, which is likely to be the main impurity in the sample of aspirin. Okay, so the main impurity could be, like, for example, we don't know how much 2-hydroxybenzoic acid we need. So what you can do, so after the reaction, it is highly likely that we will have excess to hydroxybenzoic acid. That means this will be one of the main impurities, since it is the excess left out. So this will be the main impurity for this reaction. Okay, number 12 is Kriegler's reagents are very useful for increasing the length of the carbon chain of organic compounds. Which metal is involved in the formation of a Kriegler reagent? We know this should be memorized, that magnesium, not manganese. Magnesium is used as the Kriegler's reagent. What best describes the role of a Kriegler reagent in increasing the length of a carbon chain? You should know this, that it is a nucleophile, because so Kriegler's reagent actually donates electrons. So this would be a nucleophile. Propanoyl chloride and N-methylpropylamine reacts to form an amide and hydrogen chloride. The structure of the reactants are shown. Okay, now what is the structure of the amide from? See here, the reaction will happen between this H will break off, and this Cl will break off, and this N will actually bond with this C, right? And the extra byproduct will be HCl. So any structure that shows this CO, no, not this one, not this one either, because here we have two CH3s, but here we didn't. We have a straight chain of carbon. So the only straight chain, okay, D shows a straight chain. See, there here one, two, three carbon atoms, similarly to this, 3 carbon chains bonded with the N, and the other carbon is this, right? The other CH3 is this. So this is our desired product. If 64.3 grams of amide is produced, what volume of HCl is formed at room temperature and pressure? Okay, so 64.3 gram of amide is produced. So this is the amide, and this we can find out the mole of this amide. So mole is 64.3 divided. What is the? We need to find out the um, um, MR of this amide. So the MR would be what? How many carbons are there? 1, 2, 3, 4, 5, 6. So 6 carbons. So 6 times 12 plus so not 6, 7 actually. 1, 2, 3, 4, 5, 6, 7. So 7 times 12 plus nitrogen is 14 plus oxygen is 16 plus the rest are hydrogen. So here are 3 hydrogen, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, so 15 hydrogen. So this gives us 7 times 12. So 7 times 12 plus 14 plus 16 plus 15 is 129. 129. Okay, so therefore this is mole 64.3 divided by 129, and this is 64.3 divided by, the answer is 0. We can write 0.5, so 0.5 moles. Therefore 0.5 moles of HCl is produced. So 0.5 mole of HCl will give what? 0.5 times 24 equals 12 cubic decimeters. So our answer is A. Next, we move on to section B. Question number 14. This tells us that this question is about cell reactions. Okay, number A says that name the type of forward reaction that is shown in the right hand electrode system in the data booklet. We know that in the data booklet reactions are given like this. So the reactions will be like this. To Mg2 plus will become Mg and plus 2E minus. These are always like this, right? So these are always reductions. Always reductions are shown in the data booklet. So this is reduction, and the name of the series is, you know that it's standard electropotential series. So this is an easy answer. Question okay, B says that a student set up the following apparatus to measure the standard electrode potential for right hand electrode system 8. Okay, you go to your data booklet and search for the in the standard electrode potential series, you search for the number 8, and number 8 is actually you'll find the number H is actually cerium, right? This is, sorry, not cerium, chromium. So chromium 3 plus 2, chromium 2 plus is given. So here, so that means our Y, the solution should be, so we're asked to identify X and Y, our Y should be a solution of chromium 2 plus and chromium 3 plus. And the electrode, it must be an inert electrode, like it should not react with any of the reactants, therefore it will be platinum, or you can use graphite, but platinum is the safest, so just use platinum. Give 2 reasons why the initial reading on the voltmeter may differ from the stated value. Okay, so it might differ because maybe the temperature is not standard, maybe temperature is varying, or it might be because the salt bridge is saturated, which is why the electrons are not transferred as readily. It might be also due to other various reasons. It could be because the voltmeter is faulty. It could be because the wire and the resistance of the wire is too much, right? It could be various reasons. You just have to write any one of them, any 2 of them, for 2 marks. Number 3, the voltmeter is removed and the cell is allowed to run for 1 hour. Explain the change that would occur in the so what is happening in this electrode? In this electrode, the reduction of copper or of chromium is going on. Therefore, we'll see that since the E cell is plus 0.41, the reaction proceeds forward. That means the concentration of chromium 2 plus ions is decreasing, and so what is going on? So chromium 2 plus is converting into chromium 3 plus. Therefore, the concentration of chromium 2 plus will decrease, and the concentration of chromium 3 plus will increase. Okay, explain by calculating E cell values why Fe2 plus ions is used to reduce copper chromium 6 to chromium 3, but zinc is used to reduce. Okay, so if you go to your data booklet, you will find that the relevant equations, what equations do we need? We need Fe2 plus to Fe3 plus, and we need Zn to Zn2 plus, and we need any 2 reactions for chromium, right? So one for chromium 7 to chromium 2, one for chromium 7 to chromium 6 to chromium 3. So you'll see that this values, like this numbers 5, 8, 21, 28 numbered standard electropotential reactions are our necessary reactions, And why is iron 2 used for converting chromium 6 to chromium 3 but not for chromium 6 to chromium 2? This is because, see, zinc can convert chromium 6 to chromium 3 because the E cell value for this reaction would be plus 2.09. So this is thermodynamically feasible. And then Zn can also reduce chromium 3 to chromium 2 because then the E cell value would be plus 0.35 volt, right? So this is also thermodynamically feasible. But for iron, iron can only convert iron chromium 6 to chromium 3 because for this reaction, the E cell value is positive. But when we try to convert chromium 3 to chromium 2, the E cell value comes out as negative. That means this reaction is not thermodynamically feasible. So iron is incapable of reducing chromium 3 to chromium 2. State the essential condition required for these reactions to occur. So for these reactions, obviously, we need an acidic condition, because if you look at the data booklet, you'll see that the conversion from chromium 6 to chromium 3 requires acidic condition. Moving on to question 15. 2,6 dichlorophenol is used for communication between ticks, small parasites that can infect animals, including humans. Okay, this is the compound. Okay, this compound can be synthesized in the laboratory from phenol, and we are given a step-by-step the steps for the formation of 2,6-dichlorophenol. Now the question is, the sulfonation of phenol is similar to the sulfonation of benzene. Suggest the reagent. So for sulfonation, we always add concentrated sulfuric acid, right? The concentrated sulfuric acid is the only reagent that we need for sulfonation. And deduce the structure of intermediate B compound. Okay, so what is intermediate B? So at first, reaction A occurs where we sulfonate the phenol, and so this compound is formed, and then we chlorinate this. We chlorinate this compound, and an intermediate B is formed. So what is the structure of the sulfur of 4-phenyl sulfonic acid? The structure of 4-phenyl sulfonic acid is this. Here we have the OH, and at carbon number 4 we have SO3H, right? And so after chlorination, so the chlorine will actually attack this carbon 2 and carbon 6 here, and will attach to this, and therefore the intermediate formed at B would be this. Explain why the reaction of chlorine with phenol occurs under milder conditions than the reaction of chlorine with benzene. Okay, so chlorine will readily react with phenol, but not with benzene. Why is the reason? So the lone pairs on oxygen atom from the OH, so phenol has an OH right here. If I draw the structure again, phenol has an OH. So there are two lone pairs. These lone pairs will actually overlap with this benzene ring, right, with the delocalized pi bonds in the benzene ring, and this increases the electron density inside this ring. And since the electron density increases, that means this ring is now more susceptible to an electrophile attack. And here chlorine is an electrophile, so that this electrophile, it will be more susceptible to this electrophilic attack, and therefore it will form a compound more easily than only benzene. An alternative synthesis of 2,6-dichlorophenol starts with compound C. Compound C is chlorinated. Okay, this compound C is chlorinated and hydrolyzed, and then the CO2 group is removed by decarboxylation to form 2,6-dichlorophenyl. Okay, phenol. Other than phenol, name the functional group. So here we have the phenol group, the hydroxy group, which because of the presence of hydroxy group we call it phenol. But also we have this group, and now this group is an ester, right? So COO and connected with another carbon chain. So this is an ester group. Identify 3 factors that organic chemists would take into account when considering alternative methods for an organic synthesis. So for a new organic synthesis, they would have to keep in mind about the yield, like how much, what is the percentage amount that will be formed, that the product is formed from a specific reagent. So they have to keep in mind about the yield. They have to keep in mind about the reaction conditions. What are the how much temperature we need, right? What are the catalysts we need? So they have to keep in mind about the reaction conditions, and also they have to keep in mind about the cost of reagent, because for an alternative method, you want the cost to be reduced, not be the cost to be higher. Because if the cost is higher, it doesn't make sense to change it to to move on to a alternative method. So if the cost is lower, so we have to consider the cost of reagent. If it's lower, then it's better to do it with the alternative method. Next, we have the mass spectrum of 2,6-dichlorophenol, and explain the relative intensities of the peaks at value 162, 164, and 166. So here you can see that 162 is here. It's a big peak. Then 164 and 166. Now, if you calculate the ratio, here it's 90, like at around 90. Here it is at 60, and here it is at 10. So if you calculate the ratio, it's 9:6:1. That means, so we know that chlorine has two isotopes, right? Chlorine has two isotopes, chlorine 35 and chlorine 37. Now, chlorine 35 is more abundant. That means it will give a more higher peak. So since the peak at 162 is the highest, that means it contains two chlorine, both of the chlorines, like here in the compound, both of the chlorines are chlorine 35, and for peak at 164, it is in the middle, like so. This refers that there is one chlorine 35 and one chlorine 37, and for the least peak, the least highest peak, the peak at 166, it will contain chlorine 37, right? Because chlorine 37 is the least abundant. The abundancy ratio is 75:25 for chlorine. 75 is for chlorine 35, and 25 is for chlorine 37. Such is why there is a corresponding set of peaks at 163, 165, and 167. This could be due to the presence of a carbon-13 isotope, like a different isotope of carbon, only one carbon-13 isotope, or a different isotope of hydrogen, like hydrogen-2. So this is the only explanation that could give rise to the peaks at 163 and 165 or 167. Moving on to the next question. We have question 16 here. Metal ions occur naturally in river water, but near industrial plants, the concentration can reach toxic levels. Wastewater from a stainless steel electropolishing plant contains dangerous. Okay, this is unnecessary information. Then we have chemical precipitation can be used to remove these ions from the water. Complete the equation for the reaction of a laboratory reagent with aqueous iron 3 plus ions to produce a precipitate. Okay, so it's easy to figure out that Fe3 plus. So what is some a radical that could react with Fe3 plus and will produce a precipitate? We already know that all carbonates are solids, right? All carbonates are solids. Almost all carbonates are solids. That means if we react this iron 3 plus with a carbonate, it will produce a precipitate, a solid precipitate. So we give this, so CO3 2 minus produce Fe2CO3 3, and this 6 H2Os, right? So this will come out and produce 12 waters. So this is our reaction. Then B, sodium methyl sodium dimethyl carbamate can also be used to precipitate metal ions from wastewater in acidic solutions. Okay, this is our ligand. Now complete the table. Okay, so here charge on nickel ion was +2. This is because the overall, what is the overall charge of this ligand? It's 1 minus, right? So and we know that each compound of this is only 1 minus charged. So therefore, if and only if the nickel was +2, and we have three of the ligands, so -3 would give -1, which is our overall charge for the ligand. Therefore, nickel was definitely 2 plus. What is the type of ligand? This is a bidentate ligand, since each of the ligands is bonded with two hands of the nickel. Therefore, it's a bidentate ligand. Then coordination number of nickel is, we already know the coordination number of nickel is 6, and also you can find out from here. So we here nickel is bonded with 6 different covalent bonds. So this is 6, and the shape of the metal, since there are 6 bonds, so definitely the shape of the metal would be octahedral. Question 2. Explain using a balanced equation why the formation of this complex from an aqueous solution of nickel ions is thermodynamically feasible. Okay, you can explain it with since we don't have the E cell values, that means so we can explain this with the increase in entropy. So if the entropy increases, this is more that reaction is more thermodynamically feasible. So here is the reaction. So Ni was a ligand with Ni previously we had a ligand with water, but then when we added this a ligand, the ligands shifted, and therefore these six water ligands comes out of the equation. So previously we had in total of 4 moles, and after the reaction we have in total of 7 moles. That means since the number of particles increased, that means the entropy has increased, and therefore this reaction is thermodynamically feasible. Next question says, when a 5 cubic decimeter sample of wastewater was treated with excess acidified sodium dimethyl dithiocarbamate, 245 milligrams of the dry ether precipitate was formed. Calculate the concentration in mole per cubic decimeter of nickel ions in the sample. So from this we have the mass of the ligand, so we can calculate the concentration in gram per cubic decimeter of the ligand, right? So just convert the milligram to gram and divide it by 5. This is because the initial sample had 5 cubic decimeter, but we need in 1 cubic decimeter, right? So we divide it by 5 to get the concentration in gram per cubic decimeter. And now just convert this value, this gram, this mass, to mole, and finally we'll have the concentration in mole per cubic decimeter. So mole would be 0.049 divided by the MR of this ligand, and this gives us this 1.17 into 10 to the power minus 4. Therefore this is our required concentration. Question 17. Phenyl glycine is an amino acid which can be synthesized from benzene. Okay. Now the first step of the synthesis is the formation of methyl benzene from benzene and chloromethane. Okay. So we have to draw the mechanism of the formation of methyl benzene. Now you have done it a lot. It should be memorized by now that this the electrons from the pi bond actually gives their donates their electrons to this CH3 plus radical, and so a intermediate is formed, where since this carbon gave its electron to this carbon, so this carbon actually now lacks 1 electron, therefore the entire ring is at a positive charge. And then what happens, then this hydrogen bond breaks, and this hydrogen gives its electron to this intermediate, and so this hydrogen breaks free and forms plus H plus, and methyl benzene is produced. One of the steps in the synthesis is shown. Explain with reference to the mechanism why this step in the reaction sequence will not produce a single isomer. Oh, this is because here you can see that this CN, this is a it's a planar molecule, right? This doesn't have any rotation. This can be, so since this is a planar molecule, the attack by the Cn minus electrophile can be from anywhere. This could be from this side, or this could be from this side. So since the reaction produces a pair of, therefore the reaction produces a pair of enantiomers, and as the molecule is planar, the Cn minus can attack from either side, and therefore two different isomers will form. Okay, the final step in the synthesis is shown. This is the final step, and what happens? This CN is hydrolyzed to a carboxylic acid group. So the reaction type is hydrolysis. The reagent used is obviously and in acidic solution, right? We use acidic environment for this hydrolysis, and the conditions are heating with reflux, right? So for this kind of reaction, what we do, we add H2SO4 like H2SO4, and then we heat them, heat and reflux this, um, reflux the solution, and we get hydrolysis. Next question is question number 18. Fuel cells are an alternative to internal combustion engines and batteries for powering vehicles. Okay, so explain how a fuel cell works. Okay, how a fuel cell works, what does a fuel cell do? A fuel cell uses the energy that is released from the reaction that happens inside here. So the energy that is released from this reaction is used to produce electricity, or basically to generate voltage. So this is the work of a fuel cell. Fuel cells generate voltage from what? From the chemical reactions that happen inside the fuel cell. Okay, then we have to discuss their advantage and disadvantage. So what is the advantage and disadvantage of a fuel cell? A fuel cell, so consider a hydrogen fuel cell. So the advantages of a hydrogen fuel cell is that the byproduct produced is water and not CO2, which is for combustion vehicles. The CO2 is a greenhouse gas. This is problematic to the environment, but water, it doesn't have any it doesn't have any complications. And one disadvantage of a hydrogen fuel cell would be that the storage and also the liquidification of H2 is costly, and also the storage of H2 is difficult. So that is one disadvantage. Now, now the next part of the question was to write the half equations for the electrode reaction. So for the anode reaction, we know for the anode reaction what happens in anode, ions lose their electrons. So here hydrogen or H2 will lose its electron to form H plus, and in cathode ions receive or accept electrons, therefore O2. So here H plus will actually receive 4 electrons and become and form water. You should memorize these two anode and cathode reactions for the hydrogen fuel cells because these are really important and it can come in your question paper. And also they asked us to give an example of another fuel suitable for use in fuel cells. So another fuel could be methanol. You can also write ethanol, etc. Moving on to the next question, question number 19. Okay, so in recent years there have been health and safety concerns about liquid tabs. These are capsules which contain concentrated liquid detergents. Okay, some liquid tabs are small and colorful, which makes them attractive to young children who may be tempted to put them in their mouth or play with them. When moist liquid tabs can burst in a child's hand, potentially irritating the eyes and skin. And they can also dissolve quickly and may burst in a child's mouth in a very short period of time. This allows the contents to escape quickly, and if swallowed, can cause severe breathing difficulties. Identify the hazard symbol that should be displayed on a box of liquid tabs using ticks. Okay, so we say that they can burst at any time, right? They can burst. So here they can burst at any time. They can burst in a child's mouth and stuff. So the only correct symbol would be this. See, this is the symbol for bursting. This is flame. This is like flammable, and this is for explosion. But this is bursting. So this is our correct answer. Now for B, the capsule containing the detergent is often made from polyethanol, and its derivatives. So draw the structure of polyethanol showing 3 repetitive units. Okay, we were asked to show 3 repetitive units. I'm sorry, I showed only 2. But if you continue this, so OH, H, C, H, H. This is 1 repetitive unit. This is the second one, and this would be the third one. So this would be, or not this one. This is 2 repetitive units. This is 3 repetitive units. This would be the structures, and this is the structure of ethanol, right? So when forming a polymer, this double bond breaks, and it forms another hand, which just connects with another carbon from this side. So this is our required polymer. Use your structure from 19b1 to calculate the percentage of hydroxyl groups per mass in the polymer. So here we can see that for these 2 repetitive units, since I used 2, the answer would be the same you don't have to worry, but I'll just use 2. So for this polymer we had 2 hydroxyl groups. So 2 hydroxyl groups have the mass of 34, and the entire polymer, the mass of the entire polymer was what? 12 times 4 plus 16 times 2 plus 8 equals 88, and therefore for the percentage we can just divide 34 by 88, and this will give us 38.6%. You can also do it with this. For this polymer it will be 3 hydroxyl groups, right? It will be 3 hydroxyl groups. So therefore the mass would be 3 times 17, and the total mass would be, so how many carbons do we have? 1 2 3 4 5 6. So 6 times 12 plus 3 times 17 plus how many hydrogens? 1 2 3 4 5 6 7 8 9. So whatever comes, and then you can just divide. We can just do 3 into 17 divided by this value into 100. This will give a similar results like 38.6%. Moving to question 2, explain why polyethanol is soluble in water using your answer from 19B1 and 2. Okay, so here you can see that this polyethanol uses hydroxyl group OH. Now OH can actually form hydrogen bonds with water molecules. The OH group present can form hydrogen bond with water molecules, right? And also since each molecule of ethanol has a higher percentage, like almost 38 or almost 40% of the compound is the hydroxyl group. That means there is a higher percentage. That means more and more hydrogen bonds will form, and therefore it's very, very soluble. In liquid type detergents, glycerol is added to the polyethanol. Okay, we have to find out the IUPAC name. So here you can see that all the carbons, like the 3 carbons, all of them have hydroxyl groups. So what do we call this? We call this all, right? Because these are like alcohol groups. These are all alcohol groups. So the last name is all. Therefore, we have a triol, a triol, and in which carbon atom are these alcohol groups or hydroxyl groups bonded? So it's in 1, 2, and 3. Therefore, it will be, the name would be propane, since it's a propane, like this is a propane group, right? Since we have in total 3 carbon atoms. So propane 1, 2, 3 triol. Question 2, suggest one way that the properties of polyethanol will be improved by the use of glycerol apart from any effect of solubility. Okay, obviously glycerol increases the solubility, but also it will increase the strength and flexibility of this polymer because of the greater carbon chains. Increased carbon chains will increase the strength and flexibility of the polymer. Glycerol is added to the polymer at 0.110% by volume, and then calculate the number of moles of glycerol added to 1 ton of polyethanol. So we have 1 ton, that means 1000 kg. 1000 kg in grams is 1000 times 1000, right? And then we have the density of glycerol and density of ethanol. So at first we find out the volume of polyethanol. Volume is what? So we know the formula for density. So density is equal to mass by volume. Therefore, volume equal to mass by density. We did that. So this is mass in grams divided by the density is this, and volume of glycerol needed. What was the volume of glycerol we needed? This is this times 0.110 divided by 100, since this is the percentage of glycerol that we need. So we found the volume of glycerol, and therefore from here we can find out the mass of glycerol. So mass would be what? Mass would be density times volume. We know the volume, we know the density. So this is the mass of glycerol. And from here, since we have the mass, we can find out the mole. So mole equals mass divided by mR. The mR of glycerol is 92. So we have 12.66 moles of glycerol. Question D, polyethanol is made from a polymer intermediate rather than by polymerization, as ethanol is unstable. The polymer intermediate is prepared from a monomer X. When 1 mole of X is burned in excess oxygen, 95.6 cubic decimeter of carbon dioxide and 54.1 gram of water are formed. The infrared spectrum of the monomer is shown. Okay, so 95.6 cubic decimeter. That means if we calculate the mole of carbon dioxide formed, so 95.6 divided by 24 would give us 4 moles of CO2. That means there are 4 carbon atoms. Similarly, there was 54.1 gram of water. Divide this by their mR, by the mR of water. We have 3 moles of H2O. That means we have 6 hydrogen atoms. Now, if we look at this, so P and Q is at like around 1650-ish. and P is around 1735 or 1730. So if you look at your data booklet, you will see that if you look at a data booklet, that 1735 to 1750 is an ester. Indicates an ester, and the range of the peak range from 1669 to 1645 indicates an alkane. That means we will have both an ester and an alkane. So if you take these conditions into account, that we will have 4 carbon atoms, 6 hydrogen atoms, an ester group, and an alkane group, then this is our uh, compound that will be formed. So here we have an ester group, this is an ester group, this is the alkene, and in total we have 1, 2, 3, 4 carbon atoms, and 3 here, 3, 4, 5, and 6 hydrogen atoms. Moving on to the next question. This is our last question. Some hospitals use polyethanol laundry bags instead of reusable, washable polyester or nylon bags. State 2 advantages. So advantage would be, since these are soluble, that means we don't have to wash them. We can just dump it in water and it will just become soluble. It will vanish. And also it is due to the risk of cross contamination, because since this is not used twice, these bags are not exchanging hands. Therefore cross contamination is eliminated. Hope you understood this paper, since this is the end of the paper. Best of luck for your exams. Hope you ace your exams, and if you have any further problems, do knock exam essentials. They have